Hello students, I hope you all are doing good and preparing well for KCET exam. So in today's session, we will be covering indefinite integrals. So this is an important chapter. You can expect around 3 to 4 marks from this chapter. Okay, and this chapter requires a lot of practice. Okay, you need to practice many problems. When you practice more problems, only then you will be able to identify the logic behind the question, and you will be able to solve it in your examination. Okay, and one more thing I would suggest you is pause the video and try to solve the question on your own, and if you're not able to, only then look at the solution part. Okay, this way you will be able to develop your problem solving skills. Okay, moving on. Okay, uh, what have we got? So whenever you are approaching integration questions, there is one trick that you can use. This is a very important trick. Okay, it is very useful trick. So say what is integration? Integration is reverse of differentiation. Everyone agrees, right? If this is f of x is equal to f of x plus c, that means f dash of x is equal to f of x. Everyone agrees, right? So whatever I get after integrating, say I am getting f of x, the differentiation of that will be my this function f of x. Okay. So while solving questions of indefinite integrals, the thing that we need to do is we need to differentiate the options. The one thing we can do is we can differentiate the options. Differentiate. Let me write it down. Differentiate. Differentiate the options and check whether whether they match with the given options. If they match, we can directly say that that is the uh, answer. Okay, this is one technique. The other methods that we have is substitution method. Substitution method of solving integration questions. The second one is by partial fractions, and the third one is by integration by parts. Okay, integration by parts. So these are the three important techniques that we should know, we should look for while solving questions on integration: the substitution method, the partial fractions, and the integration by parts, and differentiating the options and looking at which one of them matches. Okay, so in this case, if you look closely, what we have got, let me write down the integral. Okay, x cube sine of tan inverse of x power 4 1 plus x power 8 dx. So this is our question. Okay, so see, mostly we'll be using only these three techniques, most questions. So here I can see that I can use my substitution method. See how did I get an idea that I should use a substitution method? We know what is differentiation of tan inverse x. What is differentiation of tan inverse x? Let me write it down. D by dx of tan inverse of x is equal to 1 by 1 plus x square. Okay, so can I use that here somewhere? If I substitute, make a substitution of t equal to tan inverse of x power 4, I think I can solve this. Okay, let me check. dt by dx is equal to 1 by 1 plus x power 8. Differentiation of x power 4 is 4x cube. Okay, so I need to replace dx. Okay, so our dx is nothing but dt by 4 is equal to dx 4 d 4x cube dx, sorry, 4x cube dx by 1 plus x power 8. So I can replace that here, right? Let me just replace that. So sorry, this is just x cube dx by 1 plus x power 8. So if I replace that, what do I get? I get 1 by 4 uh, t dt, right? On replacing by substitution method. What is integration of t? What is sorry, sine t, not t, because it is, we have taken tan inverse of x power 4 as t. So here we are left with sine t dt. sine t dt. What is integration of sine? Minus cos t. Minus cos t dt, and again I'll replace, sorry, dt is gone, plus c. What is my t? T is nothing but tan inverse of x power 4. 1 by 4 minus cos of tan inverse of x power 4 plus c. Which of the option matches? I think option A matches, right? Minus, right? Yeah. Okay, so this is how you approach the question. You look at the question and see what I can do. Looking at this, we will get an idea. We have got a tan inverse, we have got 1 plus x power 8. So, okay, what I can do? I've got x cube, x power 4. There is a relation between x power 4 and x cube. When we differentiate, we get a relation between them. So that is how you approach these kind of questions. So this can be easily solved in a minute, but I have done it step by step. So it took me more time. Okay, moving on. Okay, looking at here again, they are asking us to find the value of this integral x square divided by root of x power 6 plus a power 6 dx. Let me just write that down once. X square x power 6 plus a power 6 dx. Okay, so to solve this kind of questions, we know our standard formula for 1 by x square root of x square plus a square. What is the formula? Log of x plus root of x square plus a square. This is our standard formula. So we have to make some simplification so that this becomes in this form. Okay, what I can do? See, I can substitute t equal to x cube. Okay, now let me transform this. This is my x square. X cube I can write it as x power 6 as x cube whole square plus a cube whole square dx. Okay, now I want to substitute t equal to x cube. So dt by dx is nothing but 3x square. So I can replace my x square dx as dt by 3, right? And this as t square plus a cube whole square dt. So what is this? This is nothing but 1 by 3 log of t plus root of t square plus a power 6, right? So again I can replace my t with x cube. So what do I get? The correct answer is option A, right? So, or sorry, 1 by 3, no? So the correct answer is option C. Okay, so this is how you approach this kind of question. We know this direct formula, the standard formula. How can we apply our standard formula to the given question? We have to mold the question so that it comes in the standard form. Then we apply our direct formula, the standard formula. Okay, this is the way you need to approach the questions. Okay, moving on. Okay, so this question was asked twice. Okay, integral. So what is the question? Integral x e power x dx by 1 plus x whole square. Okay, so whenever there is a e power x given, remember this formula. This is a standard result. You can just remember e power x f of x plus f dash of x dx is equal to directly e power x f of x. Okay, this is a standard result you need to know. So I know this standard result. How can I apply this to this question? So I have to make some changes, right? Okay, so this is how you approach this kind of questions. So what changes I need to make so that it comes in that form? E power x. Here what I will be doing is I will be doing x plus 1 minus 1. This is nothing but x only, right? 1 plus x whole square dx. Now I can write this as x plus 1 by x plus 1 whole square minus 1 by x plus 1, right? Now my x plus 1 and x plus 1 gets cancelled, right? Now I am left with e power x 1 by x plus 1 minus 1 by x plus 1 whole square, right? So I know, right, for these kind of questions, if this is my f of x, this is my f dash of x, right? You can check that out. Differentiation of 1 by 1 by x plus 1 is nothing but minus 1 by x plus 1 whole square. That means the answer to this question is e power x 1 by x plus 1, right? Dx, sorry, c, the constant of integrity, constant. Okay, so this is my correct answer. Which one of them fits? The correct answer is option D. So this was asked twice in 2015 and 2021. So this is the way you need to approach the question. Moving on, again similar question. We have got a e power x, so somehow we have to bring it to the standard form. Let us see, let us break it down. On breaking down, what do I get? Let me check. E power x 1 plus sin x 1 plus cos x dx. Okay, on splitting, what do I get? 1 by 1 plus cos x plus sin x by 1 plus cos x, right? Okay, so now you need to use your trigonometry knowledge here. E power x, look at the options also. We have got e power x tan x by 2, e power tan x 1 plus sin x 1 plus cos x. So it is something like, if this is our f of x, the other term is f dash of x, right? So I need to simplify. It is in terms of tan. Okay, we know what is 1 plus cos x, right? It is nothing but I can write it as 2 cos square x by 2, right? Basic trigonometry. Sin x, I can write it as 2 sin x by 2 cos x by 2, and 1 plus cos x as 2 cos square x by 2, right? Cos x by 2, cos x by 2 gets cancelled. What am I left with? E power x 1 by, sorry, 2. I can write this as sec square x by 2, sec square x by 2 plus 2 gets cancelled, tan x by 2. Okay, see, it is again in that form. What is our standard formula? E power x f of x plus f dash of x. What do I get? E power x f of x, right? So what is my f of x? Here my f of x is nothing but tan x by 2. I can check that out. See, tan x by 2, f dash of x. What is f dash of x? Differentiation of tan x by 2 is sec square x by 2. Differentiation of x by 2 is 1 by 2. So see, I have got the same thing. So this comes in the denominator. I'm so sorry. Okay, so we have got that form. So I can directly write it as e power x tan x by 2. So the correct answer is option A. So this is how you solve these kind of questions. Okay. Okay, moving on. Okay, this is an interesting question we have got. Okay, how do you solve this? Sine square x divided by 1 plus cos x dx. Okay. Mhm. I have to make some substitution here. We know differentiation of cos x is sin x. Okay, let me look at the question, the options. We have got x minus sin x, x plus sin x. Okay. Mm, 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 yeah, I'm getting something here. I can write sine square as 1 minus cos square x. Everyone agrees, I guess. It is all about trigonometry. Okay, how well you are with your trigonometry formulas will help you here. So I can write 1 minus cos square x as 1 minus cos x 1 plus cos x a square minus b square, right? 1 plus cos x divided by 1 plus cos x, okay, dx. So this gets cancelled. I'm left with 1 minus cos x. Integration of 1 minus cos x is a very easy thing. Anybody can solve this. So integration of 1 is x, integration of cos x is sin x, and the constant of integration. So the correct answer is option A, I guess. Okay, so this is how you need to look at the question, observe it, make some simplification in the question, and then simplify it and arrive at the solution. Okay, moving on. Okay, what have we got? We have got e power sin x sin 2x. Okay, the first step I can do is I can break this down. I can break down sin 2x as 2 sin x cos x. Okay, simple trigonometry. 2 sin x cos x. And I also know that differentiation of sin x is cos x. So I'll pick substitution method, t equal to sin x, and I know dt by dx is nothing but cos x. So I'll just substitute that e power t 2 sinus t cos x dx is nothing but dt. Okay, so how do I solve this? I can use by parts, integration by parts. So I'll keep 2 outside. I'll get t integration of e power t is e power t minus integration of e power t differentiation of t is 1, right? I have done integration by parts. Okay, t e power t minus e power t, right? I'll just substitute what is our t. T is nothing but sin x. Sin x. Okay, I can take e power t common, right? Okay, let me just take that. Let me take e power t common, 2 e power t t minus 1, right? So 2 e power sin x sin x minus 1. Okay, which of the following matches? Okay, correct answer is option A, plus C, constant of integration. Don't forget this. Okay, moving on. So what we did the substitution method, then we went to the integration by parts. Okay, so those are the only methods, 3 methods: integration by substitution, integration by partial fractions, and the third one is integration by parts. Only these 3 techniques we can apply and solve the question. Moving on. Okay, so this is an interesting question. This was asked in 2020. So you need to solve this in a less amount of time. So here we can apply the partial fractions method to solve the question. Okay, so what have we got? Looking at the question only, we can make out that this can be solved using partial fractions. Okay, but they have already given us the integral a log x minus 1 plus b log x minus 2 plus c log x minus 3 plus c is the constant of integration. Then the values of a, b, and c are, so they are asking us the values of that. Okay, so this is interesting. So how can we solve this in a minute? Okay, we cannot use up the time is an important thing here. Okay, so I know I have to write it in split it as I have to write it in partial fractions form and find out the values of a, b, and c, and I'll arrive at the answer. But how can we solve this faster? That is the thing. Okay, let me just simplify. Let's at least do the second step. I'll show you the technique to solve this type of questions. X minus 3 plus b uh, x minus 1 and x minus 3 plus c x minus 1 and x minus 2. Okay, so here what do? We simplify everything and we equate the coefficients. Whatever is the coefficient of x here, I equate it with 3. Whatever is the constant I get, I equate it to 1, right? This is how we do. Okay, so here what do? I get x square terms, I get x, I get 1, I get some constant term here when I simplify this, right? I know what is the constant term. Constant term is equal to 1. So what I would be doing is I will only take the constant term. I'll forget about the entire multiplication. So when I multiply this, what is the constant that I'll get? I'll get 6, right? 2 into 3. And the other terms I get is it will have an x and it will have x square. Okay, so I don't want them. I want only the terms that are free of the variable. So 2 3s are 6. In this case, what do I get? Okay, so this is the short, faster technique to solve question. Here I'll get 3, right? Forget about the x square and the x term. We just forget. Only the term that is free of the variable. Look, focus only on that. Here I'll get 2, right? Okay, and these are our constant terms. This should be equal to 1, right? This should be equal to 1. Okay. So now what I'll do, substitute the options and check. Let me check whether option 1 fits. 5 comma, I have got 5 comma minus 7 comma minus 5. Let me just put that. 5 times of 6 plus minus 7 times of 3 plus minus 5 times of 2. I get 30 plus 21 minus minus 10, right? So this is minus 21. Sorry, 7 3 is a 21, no, right? Okay, so what do I get? I get 10, 10, 10, minus 1. Okay, I'm getting minus 1. But minus it should be equal to 1, right? So this is not our correct answer. Let's substitute the other option that we have got, the option B, 2 comma minus 7 comma minus 5. What do I get? 6 2s are 12, 7 3s are 21, 5 5 2s are 10, right? 5 2s are 10. Okay, again this is not equal to 1. This will give me some other value. What is our option C? Coming to the option C, we have got 5 minus 7 and 5. 5 6 are 30, 7 3s are 21, and 5 2s are 10. Okay, even this is not going to work. No, this is not going to work. Coming to our option D, I'm so sorry, I'm short of space here. 1 second, I'll just scroll down slightly. So my option D is 2 comma minus 7 comma 5. Let me just substitute that in 6a plus 3b plus 2c. I should get this as equal to 1. I hope we get 3 times of minus 7 plus 2 times of 5. 6 2s are 12 minus 21, 2 5s are 10. Yeah, we'll get 1 right here. 22 minus 21 is 1. Okay, so our option D is correct here. Okay, so this is the, you can, there might be other methods through which we can solve. This is one method where you can that you can use to solve this question. So what I have done here, I have not evaluated the entire thing. I only took the term that is constant, that is free of the variable. I substitute, I know that is equal to 1. I took the options and substituted in it, and I found out. So this is a very this way you have to approach so the questions. Okay, moving on. Next question. Again, we have got e power x here. Okay, interesting. And we have got cos square of e power x x. Okay, let me just write the question. Okay, we need to observe. Observing the question is very important in the integration. Okay, the answer is within the question only. Okay, but you need to know the techniques, right? Okay, I can simplify this and write e power x 1 plus x. I can write cos square 1 by cos square x as sec square e power x dot x. Agrees everyone? Okay. Okay, we know that differentiation of tan is sec square x. Differentiation of tan x is sec square x. Okay, so this is something related to tan, either option A or option B. Okay, and we also have got x e power x. Okay, so the another technique that I told you is we can pick the options and we can differentiate it. If the differentiation gives us the question itself, then we can confirm that that is our answer. So we now know that either it is option B or option C. Let me use that method also. If we take option B, that is tan of e power x dot x. Okay, if I differentiate this, I should get the question, right? What is differentiation of tan? It is not inverse, only tan. Okay, differentiation of tan is nothing but sec square e power x x, right? What is the differentiation of the inside part? I'll be using the product rule here, e power x plus x e power x, right? Voila, we got the question back. Okay, so this is nothing but the question, right? Sec square e power x dot x. I can take e power x common. I'll get 1 plus x. Okay, so this is nothing but my question. So the correct answer is option B. So this is one way. The other thing what you could do to solve this type of question is this is the shortcut method that I told you. But the faster method to solve this would be you could make a substitution here. If you go the conventional method, there you need to put this substitution t equal to e power x dot x, because the differentiation of this is nothing but this, right? So using that substitution method also you can solve this, or the one method using the options, differentiate the given options. If they are equal to the given question, you can directly mark the correct answer. Okay, that is one technique. That is a very very smart way to solve a question. Okay, moving on. Okay, what have we got? We have got indefinite integral e power x. So whenever we have e power x, we can use that shortcut. E power x f of x plus f dash of x is nothing but e power x f of x. Okay, let me write down the question. What have I got? X square tan inverse x plus tan inverse x plus 1 divided by x square plus 1 dx. Okay, I can take tan inverse x as common. Okay, plus 1 divided by x square plus 1 dx e power x. I'm simplifying the given question. That's it. Tan inverse x plus 1 by 1, 1 plus x square. Okay, now tell me what is the answer. I hope most of you have guessed it. Okay. Uh, we know that differentiation of tan inverse x is 1 by 1 plus x square. So in this case, what do? I will use my standard result. E power x f of x. What is my f of x? F of x is nothing but tan inverse x, because differentiation of tan inverse x is 1 by 1 plus x square. So what is my correct answer? The correct answer is option A. Okay, so this is how you solve the question. So the given definite integral, try to simplify it. When you simplify it, match the standard result. You know the standard result and apply it. Okay, moving on. Okay, so this is an interesting question. So here you need to know the property of logarithms here. Okay, so let me just show you. Let's just pick e power 6 log x. Okay, it is nothing but e power log x power 6. Okay, everyone agrees here. Let me call this t. Okay, now if log x power 6 is equal to k, let me call this k. This will be e power k, right? Okay, coming back to this part. Okay, looking at this from the definition of logarithm, what can I write? Here is a e sitting. There is a e sitting here. I can write this as e power k raised to x power 6, right? From this. From this, what is my e power k now? Tell me. E power k is nothing but x power 6. Okay. So the standard result for logarithm that we have is e power log base e of anything, whatever is there here. Say y is nothing but y. So this is the standard result you need to know. Okay, please make a note of the standard result. Okay, we'll be using this result. Okay, so the question that we have got is the same thing. E power 6 log x minus e power 5 log x divided by e power 4 log x minus e power 3 log x dx. I can write this down as e power log x power 6 minus e power log x power 5 e power log x power 4 minus e power log x cube. Now using the result, I can write this as x power 6 minus x power 5 divided by x power 4 minus x cube dx. Now I can take common here. I can take x power 5 as common. I'll get x minus 1. Here I can take x cube as common. I'll get x minus 1 dx. X, it gets cancelled. I am only left with x square dx. What is integration of x square dx? It is very easy. X cube by 3 plus c. So the correct answer is option B. Okay, so this is how you solve this question. So here the important thing is you need to know this property. E power log y base e. Base e is important. So whatever is there here, we can directly write it down here. So whatever 6 was here, we know that 6 log x can be written as log x power 6. So in the first step we wrote it like that, and using the standard result we reduced it to this. Then we took common and we simplified it. We got x square, and integration of x square is nothing but x cube by 3. Moving on, what have we got? Okay, so this is an interesting question. This was also asked in 2022. The same question was asked. Okay, so let me write down the question. Cos 2x minus cos 2 theta divided by cos x minus cos theta dx. Okay, I can write cos 2x as uh, cos 2x as 1 plus no, I cannot write it. Okay, there is some trick here. Okay, okay. I can write cos 2x as 2 cos square x minus 1. Okay, standard definition of cos 2x. I can write cos 2 theta as 2 cos square theta minus 1. Okay, we are integrating it with respect to dx. Okay, so what I am doing is I am trying to get the terms in terms of x and theta. Okay, I can write 2 cos square x, 1 gets cancelled here, 1 gets cancelled, so I am left with 2 cos square x minus cos square theta divided by cos x minus cos theta. Now again I can use the property a square minus b square. A square minus b square is nothing but a minus b, a plus b. Okay, in the numerator when I use this gets cancelled, right? I am only left with cos x plus cos theta dx. Remember, we are integrating it with respect to dx. So cos theta is nothing but a constant term. What is integration of constant? Tell me. Integration of k dx is nothing but kx, right? Everyone agrees? This is very important here. Okay. So 2 I'll take out. We know what is integration of cos x. It is nothing but sin x. Integration of cos theta. Cos theta here is a constant because we are integrating it with respect to dx. Okay. So cos theta is just a constant. So I can write cos theta as cos theta x. Okay. So which of the option matches here? So the correct answer is option A, I guess. Okay. So this is how you solve these kind of question. Moving on. Okay, another interesting question we have got. So again, we'll be using the standard result for e power x questions. F of x plus f dash of x equal to e power x f of x. So this is the standard result. So somehow we have to get this to the standard form. So how we can do that? X plus 3 e power x divided by x plus 4 whole square. Okay, dx. Okay, so I have to make some simplification so that it comes in that form. So I can write my x plus 3 as x plus 4 minus 1 divided by x plus 4 whole square, right? I can write x plus 3 as x plus 4 minus 1. And why have I written it as x plus 4? Because my denominator is x plus 4 whole square. Okay, sorry. I'm so sorry. This is e power x. Okay. Okay, now I can write this as x plus 4 gets cancelled. I'm only left with x plus 4 minus 1 by x plus 4 whole square. Now it is in the standard form. We know that differentiation of 1 by x plus 4 is nothing but minus 1 by x plus 4 whole square. So directly I can write e power x 1 by x plus 4. Okay, easy question, pretty easy question. So the correct answer is option A. So okay, moving on. So moving on, what have we got? Okay, so this question looks lengthy. The options look scary. Okay, let's see. What have we got? We have got root of x square plus 2x plus 5. So this is a standard question. Standard question. We know, right? We know the standard question. We need to reduce this to uh, using the method of reducing it to squares. We solve this question, right? Okay, so on reducing, what do I get? I can write this as x plus 1 whole square plus 2 square, right? You can use the standard method, the in board level what you have used, you can do. I have written this directly. With practice, you can achieve this. Okay, so this is nothing but x plus 1 whole square plus 2 square. Okay, so we know how to integrate this. It is nothing but x plus 1 by 2 uh, x plus 1 by 2 the same thing whatever is there in the root, x square plus 2x plus 5 plus a square by 2, that is nothing but 4 by 2, and here comes the log of x is nothing but x plus 1 plus the entire thing, x square plus 2x plus 5. So this is the standard result. You can refer the textbook. I've used the standard result. You can check the integration of x square plus a square. I have used the same thing. I have applied the formula for that. Okay. I have used, sorry, let me write it down. I have used this standard result, the integration of x square plus a square dx. Okay. So which of the option matches here? I think the correct answer is uh, option op, option B. Okay, option B is the correct answer. So what we have done nothing here directly. Here actually a substitution that we have done. We are taking t is equal to x plus 1 and solving, right? Okay, so that will make it slightly easier. Moving on. Okay, so this is a slightly difficult question. The one approach that we can do is we can differentiate each of the options and check, but it is going to take us a lot of time because we have to differentiate all the four maybe in the worst case. So let's try to solve this in the conventional method. Okay, let me see. 1 plus e power x dx. I can make a substitution t equal to 1 plus e power x. So what is dt by dx? E power x. Okay, t, what is my dx? Dt by e power x. Okay, but what is e power x from this? E power x is nothing but t minus 1. I'll make that substitution again. 1 by t minus 1 dt. Okay, sorry, t minus 1. So here I can use the partial fractions, right? 1 by t plus 1 by t minus 1. Do I get? Yeah, I think I have to take a minus here. Oh, I'm so sorry. If I take minus here, that is going to work. Okay, I'll get the same thing. T minus 1 minus t, I am only left with 1. Okay, so I can integrate this, right? This is nothing but log of t minus of log of t minus 1. Okay, this again I can write it as log a by b, no? So log of t by t minus 1. So what is my t? T is nothing but 1 plus e power x. So 1 plus e power x divided by 1 plus e power x minus 1, that is e power x. So this is how you solve this type of question. The correct answer is option A. Okay, so we did a substitution here. We substituted t equal to 1 plus e power x and we solved the question. Moving on. Okay, so this is also a standard question that they have asked us. 1 by root of 3 minus 6x minus 9x square. So looking at the question, we get an idea that it is something of the form 1 by root of a square minus x square, something of this form. Okay, what is the formula for this? It is nothing but sine inverse x by a. So this idea we should get looking at the question. So all the options have sine inverse. Okay, so how can I solve this? Okay, one more thing is in each of the option there is 3x plus 1, 3x plus 1, 3x plus 1, 2x plus 1. So it is something related to 3x plus 1. Okay, we can guess that. Okay, this is how you can use the information given in the options. Okay, so I can write this as uh, what can I write? I can write this as maybe 2 square minus 3x plus 1, maybe in that form. Let me just check, will this work? 4 minus 9x square plus 6x uh, plus 1, right? No, no, minus 1, minus 1. This is minus 1. This will give me 3 minus 9x square plus 6x. Okay, 1 second, it is giving me a minus. There is some error. There is some error. Minus, 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 minus. Yes, yes, yes. I'm so sorry. This is minus, no? This is also minus. Yeah, this works. This works. This is just with guesswork and with practice you can achieve this. So 3x plus 1, I guessed it from here. I just picked up 2 square. Okay, this comes with trial and error. Okay, so I have got it in the standard form. So I know the for standard form, I know what is my x and t. So sine inverse of x by a. X is nothing but 3x plus 1. My a is 2. And because we are taking it 3x plus 1, we have to keep here 3 because the coefficient of x is 3 here. Or you could do the standard way. You can put t equal to 3x plus 1 and solve. You'll arrive at this. Okay, you'll arrive at 1 by 3 sine inverse of 3x plus 1 by 2. So the correct answer is option C. Okay, so this is how you solve this type of questions. This was a pretty easy question. Standard formula, we just need to apply that. Moving on. Okay, what have we got? We have got e power sin x plus 1 by sec x. Okay, so here I can use the substitution method, no? So e power sin x, this is a very ugly looking term. I can use this substitution, t equal to sin x. Okay, so e power t, so dt by dx is nothing but cos x. uh, I can write my 1 by sec x is nothing but the cos x. So t plus 1 dt, because 1 by sec x is nothing but cos x. So here, as you can see, differentiation of t is nothing but 1. So I can write this as e power t. Okay, the standard result for e power x f of x plus f dash of x that I am using. Again, I'll back substitute the value of t, that is sin x. So the correct answer is option A. Okay, moving on. Okay, so this is a slightly complex looking problem, but it is easy. So I cannot use here substitution method. Partial fractions, no. So by parts I can use. So integration by parts. I'll be using integration by parts to solve this question. So I'll choose x cube as my first function. Integration of sine 3x is nothing but cos 3x by 3 minus integration of cos 3x minus 3, differentiation of x cube, that is 3x square dx. So again I have to do the partial differentiation, partial integration for this term. So again here I'll choose x square as my first term, x square integration of cos 3x, so minus minus gets cancelled. Okay, plus. So x square integration of cos 3x is nothing but sine 3x by 3 minus sine 3x by 3, differentiation of x square is 2x dx. Again I have to apply once here. Okay, so let me check the two terms I have got already, minus x cube cos 3x by 3. So two terms at least I have got. So which of the fun so matches the, even in the first option, the second option, third option, all of them have. Okay, let me check the second option, the second term. This is positive, this is positive, this is negative. So either it is option B or option D. Okay, so we have eliminated two options. So again I have to apply the integration by parts rule here. So I'll get 2 by 3. First function I am keeping it as x, integration of sine 3x is nothing but minus cos 3x by 3 minus cos 3x by 3, differentiation of x is 1. So yeah, so we have come to our last term. So this term is nothing but plus 2 by 9, 2x by 9 cos 3x. So which of them? So in the option B I can see it is positive term, so here it is negative term. So as we have got positive, my option D is also eliminated. So the correct answer is option D. This is how you can solve this question. This question will take around maybe 1 minute 20 seconds, but you should know. Okay, looking at the question, you should know that you have to apply partial fractions method here. Okay, moving on. Okay, so in the question, as you can see, everywhere it is tan inverse, tan inverse, tan inverse. Okay, okay, and what we have got here, 1 plus x power 4 by 1 plus x power 6. So here I can use our smart technique. differentiating the given options and checking whether it matches the given question. Okay, so but what options I can pick? We have to pick the correct options, no, so that to reduce our time. Okay, so here I can observe one thing. In tan inverse x, if my denominator is something like this, then differentiation of x cube, I'm so sorry, so this is just trial and error thinking. I am not able to erase, yeah, I'm so sorry. Okay, this is just using logic, so I can write 1 by 1 plus x power 6 as 1 plus x cube whole square. So if I take something related to tan inverse x, so differentiating x cube will give me 3x square, right? So this 3 will be an extra thing, right? I have to get rid of this 3, so I need to have something in the denominator to get rid of this 3. Okay, so if I do that, I can eliminate my option A. Okay, it is in between any of the 3. Okay, so which one? Oh, there is some misprint. Option B and C are same here. Okay, okay, maybe this is minus. Okay, okay, let me pick. So it cannot be tan inverse of x square. Okay, it is x cube only. So it is either option B or C. I have to check it. So what is it? Okay, let me take option B, okay, and check what do I get. Tan inverse x plus 1 by 3 tan inverse of x cube. Differentiating tan inverse, I get 1 by 1 plus x square plus 1 by 3. Differentiation of tan inverse of x cube is nothing but 1 plus x cube whole square. Differentiation of x cube is 3x square. 3 gets cancelled. I'm left with 1 by 1 plus x square plus uh, plus x square by 1 plus x power 6. On simplifying this, you will get this. Okay, whatever is given in the question, you can try it. Okay, so the correct answer is option B. So there is some error with my system. I'm so sorry, guys. So that's all I have. This was the last question anyhow. uh, so I hope this session was helpful to you. So the correct answer is option B. So if this session was helpful, please like the video. You can subscribe to my channel so that you get the latest updates. I'm planning to cover each chapter's PYQ questions, so that this will help you in your exam. So you can subscribe to my channel. Okay, thank you very much.